All right, my name is John Evans. I'm an assistant professor here at Purdue University. And today I want to talk to you about some of the work we're doing in the OATS group, specifically around open source architecture for Trails. And Trails is tracking autonomous insights from location data and services. So what are Trails data? Well, it's just time series location data. So where you've been and when you've been. And this is a really common data set that we collect in precision agriculture specifically. But usually we kind of silo data into operation specific. So, if you're spraying or if you're doing some other application, you have that data for that specific application. But we really rarely look at it at a systems view. And partly because it's so hard to get all these data layers together and actually pull information from it. But we think with this location derived records, we can actually provide some really reliable and valuable insights, such as critical inputs to sustainability environmental models. Traceability is a big one. Alerts to prevent mistakes. And if we had a mistake, trying to triage to figure out what actually happened and how we can prevent it from happening in the future. As well as inputs to agronomic models, coordination with service providers, we believe is a big one. Automatic report creating for government agencies, and there's a whole host of other possibilities just from this really simple data set that a lot of people already are collecting. So the architecture that we think is going to make this possible is first, is having this, this location data sources be transmitted to a farmer's OATA conformant cloud. And so I'm sure Aaron is going to talk more about OATA and what that means. But essentially this cloud that the farmer controls that has a set standard of data that is being pushed to it. So if we can get all these location data sources up to the cloud in a similar format, well, that's a huge part of the battle, right? It's getting everything up there. And like I said, there's a lot of these data sources that are currently available, such as OEM telematics. We at Purdue developed our open source ISO Blue telematics, GPS loggers, precision ag data. All these things could provide potential insights if we can just get them together. So again, we're proposing to do that on this OATA conformant cloud. Once we have it all together on this cloud in a similar format, really the possibilities really expand. And part of what we want to do is create services that are going to tell us just based on GPS data what we think is going on in the field. So that could be things like coverage estimators, swath estimators, geofence events, operation detection, and the one I'm going to talk about most today is transfer events and level estimation. So if we can do that, now we've got this data, now we've got some, we've converted it to some information, and with that, we can actually create some apps to serve that information to the stakeholders. So like I mentioned, the enabling hardware is widely available and frankly, out there in use today. It's just not being put together. So whether it's, like I said, our OEM telematics, from providers like John Deere, off-the-shelf telematics units, open source ones like we have, and then our phones, our tablets, right? Things that are connected to the internet, these devices. We have all these things, all these technologies exist, they've existed for a long time. We just can't seem to get them together. And that's what we're proposing and working on. So again, supporting services, once we have these things in the cloud, like I mentioned, the swath detection, coverage estimation, all these things are possible and a lot more. And I'm going to show you a video here, just to show you the transfer events to level estimator and how intuitive it is. If we know where the combine and grain cart are, and we know a little bit about the system, we can get a pretty good estimation of what we think is going on. So here's an example here where you can see the two vehicles come together and you see it turn screens. Well, that's where we think that they're actually transferring grain between the combine and grain cart. So I want to talk a little bit about that today. So one of the things I'm most passionate about is harvest logistics and how we can use Trails data to enable some of that. And my dream is to come up with to enable this app that's going to let farmers or custom operators actually see what's going on in the whole system. So as we know, harvest is a huge logistical challenge, right? You've got a bunch of vehicles operating in the system, and the failure of any one of these vehicles to basically cripples the whole system. So Right now, farmers rely a lot on experience to manage these systems. But we think we can provide them some information to help them do it a little bit better. So if, for instance, the combine operator knows how much is in the grain cart, and knows where the trucks are, when they left, and maybe even when they're expected back, he can make some pretty informed decisions around how he's managing his logistics. Hopefully that will speed up, when we think that will speed up harvest times and save quite a bit of fuel and time. So again, to enable this, one of the big things or services we needed to come up with was this transfer events and level estimator. So I've had a student working on this recently, and the way they started out doing this was by actually collecting a lot of CAN data. So this is, a lot of people have done this, including myself in the past. Collect this CAN data to understand what is actually going on, or getting this truth data set. That's going to tell us, for each of these pieces of equipment, what they're actually doing in the field. So for this presentation, for the sake of time, I'm only going to talk a little bit about combine state data. And so we were looking at, trying to figure out whether it was active, idle, unloading on the go, unloading stationary, or if it was a state we just didn't understand what was going on. So a big challenge, which, in the future, we hope the OATS Performant Cloud helps us solve is this interoperability challenge, right? So this is a fairly simple operation. We collected this data from our acre research farm here at Purdue. We took some CAN data loggers, put them on the combine and tractors. We had a couple of other GPS loggers on the trucks. And even that simple operation in terms of getting that data aligned and in the right format was a challenge. And you can see the data pipeline here, all those steps we had to go through. Well, we hope with by getting that OATS Performant Cloud up and running, we can spare ourselves some of this trouble and hopefully get to actually processing information much quicker. But we were able to get through this, get everything, all the equipment in a time series. So basically, throughout the day, at any given second, we knew exactly where everything was in the field. And with our CAN data, we could do some early estimations of the truth data and what was going on. So we knew when the combine was unloading, we knew when the grain cart was unloading. So from that, we wanted to try to figure out, okay, well, what can we tell just from the GPS? So my student went through and created an algorithm with some state rules. So for the combine, he had a couple rules around, if he thought it was active, idling, unloading, either on the go or stationary. And it was some pretty basic rules to help us try to figure out what was going on. Again, just based off the GPS. So we had the truth data from the CAN data. We wanted to see if we could just figure it out from that trails data. So one of the key challenges was trying to figure out the different parameters that we needed to set our thresholds. It'd be nice if in the real world, speeds on the combine actually went to 0 when it stopped, but they don't. GPS has some inherent error, so we had to spend some time trying to figure this out. So we took one of our fields, tuned the parameters, and came up with what gave us the best correlation between that truth data set and our GPS, our trails data rules. From that, we actually apply that to 3 other fields at acre, and we're able to come up with this overall error state or error estimation for our combine state data. So the first column is the state machine, so what we predicted versus what we found with the CAN data. So on some of them we had very low errors. Some of them we were up in that 16% range. Overall, very good. I had them go back and figure out if we ever missed any events. So did they miss any unloading events? And actually, we didn't miss any events. The key thing that drove the error, especially on the combine side, were some of these leading and lag errors. So basically, that alignment time when the combine and grain cart were coming together, the way our rules were set up, as soon as they were within basically that certain threshold, it thought they were unloading. When in reality, it takes a little bit of time to get aligned and for grain to actually start being transferred. And the same thing with departing. So that showed up in our visual inspection of the data that you can see here. Another challenge was when it went from unloading on the go to stationary. So at the end of a run, if they hadn't quite finished unloading, and they stopped to finish. We struggled a little bit there. But overall, like I said, we were able to do pretty well at estimating when this thing was actually transferring material. Like I said, we didn't miss any of those events. We just were a little bit off on how long they were actually occurring. And I think that's something we can tune out. And we think we can continue to grow on this. So that was just an example of one of the services, but we definitely want to continue to grow this, work on getting that Trails data pushed to the cloud and enabling a bunch of these other services, which will in turn enable these apps, which we think can really help our stakeholders to be more efficient, spend less time on some of these things, and hopefully do a better job overall. So with that, I'm sorry I couldn't be there in person today, but I do want to thank you guys for tuning in. If you have questions, Aaron can probably answer some of them. If he can't, feel free to email me at this email address here. Thank you.